So looking at example 4 of that worksheet on growth decay. The rate of change of the number of bears. The rate of change of the number of bears. So what's that? How do I translate that? What's that equal to in terms of symbols? Well, we'll get to k in a minute, but that's dn dt. So right now I'm just trying to translate this from English to a math problem. So dn dt is directly proportional to. Now, Emily, what's that mean?
It's got the k.
It's got the k. So equals k times 1200 minus n.
Why did you put the t there too?
Well, that's not n times t, it's n of t.
Oh.
Like f of x, sometimes you could just write f.
Okay.
So it's just kind of being lazy, I guess. When t equals 0, okay, so here comes some of our table entries here, t and n. When t is 0, the population is 300. If n of 4 equals 600, so it's kind of a different way to write the thing, but that means when t is 4, there's 600 bears. Find n of 8. So when t is 8, how many bears are there? And find the limit as t goes to infinity. So, I mean, officially infinity is not really an entry on the table, but it kind of is for this problem. So now we've got all the information they gave us set up as a math problem, not just a paragraph problem. So to separate variables, dn over 1200 minus n equals k dt. What about the left-hand side there? You can do a u substitution. If you've done enough of them, you might know how to jump to the answer, but maybe we're not there yet. So let's do 1200 minus n is u. du would be negative dn. So that negative is the kind of the key part to this problem. So negative integral of du over u. And what's the integral of du over u? I hope we've seen this a gazillion times to recognize that as natural log of u. And then the other side would be kt plus c. What do you want to do next? Fishhook? Yes. Not quite though. I need to do something before I do the fishhook. Yeah, move the negative out of the way. So natural log 1200 minus n equals negative kt plus c minus c doesn't really matter. This is the c thing. I'll go plus c. But that's a different c now. Then do the loop-de-loop fishhook thing. E the negative kt plus c equals 1200 minus n. Let's see. Now it's an algebra problem. How many algebra steps can I do at once? All of them? Is that what that means? All of them. I'm going to move the n over. I'm going to subtract over the e stuff, but I'm also going to bring that c down front. So once again, two variables, right? A whole bunch of letters. Excuse me, two variables. I didn't underline the variables. Back up. 5 letters, 2 constants, 3 constants. But E I know, C and K I don't know. But they gave me 2 pieces of information, so I should be able to find C and K. All right, so let's use the. Almost always want to use the 0 stuff first because it usually makes stuff go away and works out well for us. So 300 equals 1200 minus C e to the negative k times 0. Yay, good news, because k times 0 is 0, e to the 0 is 1. So what does C equal? 900. Maybe I should have halfway boxed that, because that's sort of the final answer. I just now need to find C and K. So 1200 minus 900 e to the negative kt. Oops. Now let's use the second piece of information. 600 equals 1200 minus 900 e to the negative k times 4. So let's see, subtract 600 from both sides, then divide by negative 900. Which conveniently enough reduces quite nicely. 2/3. What do I do next, algebra students, to get k by itself? Take the natural log of both sides. So natural log of 2/3 equals negative 4k. So there's my k, and in some sense, no, a very real sense, my problem is solved. Like, I haven't answered the question yet, but I know C, I know K. Now I can answer anything they want. Now my calculus really is done. 1200 minus 900 e to the negative kt. And I'm not going to rewrite k because I've got it right there. And that's perfectly acceptable answer on a free response test for me or for AP. If you tell them what k is, you don't have to rewrite it all out. You don't have to even draw the arrow. That's just sort of saying, hey, look, I know what k is. It goes right here. I just don't want to rewrite it. The problem wants to know what n of 8 is. 1200 minus 900 e to the negative k8. And that's actually a safe stop because that's calculator ready, right? I have no idea what that is, but that's a safe stop because it's calculator ready.
So the test probably will ask, like, it won't go this far into the question. It's no calculator.
Great point. The test is no calculator, so what do I do? Well, I could go this far. I can't go any farther, but I could go this far because I haven't used the calculator yet. So that's a great question, especially on a no calculator test. Like I'm done. I can't go any further than that. And I mean that's an acceptable safe stop, but I'm curious how many bears there are at 8 years. So all natural log of 2/3 divided by -4. That's K. I'm not even going to save it as K because I'm just using it once, I think. 1200 minus 900 e to the negative answer times 8. 800 bears. That seems reasonable based on what's going on. We're increasing our number of bears. Go ahead. The infinite one. Is it infinite bears? Well, let's look at our formula here. N of t 1200 minus 900 e to the negative kt. Basically, e to the negative gazillion. Actually, well, if I didn't have a calculator, I wouldn't be able to do this maybe, but 1200 minus 900 e to the negative k times, I don't know, 1,000 years. That's a little excessive, but whatever. 1,200. So the maximum I'll get to is 1,200. Mike could see that way up here, because if n is 1,200, what's the growth rate of the bears if n is 1,200? 0. So if we reach 1,200, we're not growing anymore. And so this is actually, I think it's called logistic curve. So like the exponential growth is nice, but that's not really realistic. And when COVID was first starting and people were modeling using exponential growth, like number of cases, you're like, well, it can't go forever. Like there's a lot of people in the world, but there's not an infinite number of people in the world. And so this curve looks more like, initially it looks like exponential growth. And that's like the front end of COVID, right? Like, oh my gosh, it's going to take over the world, everybody's going to die. And then it's like, well, you know what? There's only so many people in the world. We can only fit 1,200 bears in this population. It sort of does that. And so this is exponential growth is a popular common curve, but this is almost a more realistic curve. Like how many bears can a certain habitat support? There's only so much food for them, only so many caves for them to sleep in, or whatever the limiting factors are. Is not growing past 1,200 for this example.